Hello everyone, this is Pablo from the C# Academy, and in today's tutorial we're going to build a water consumption logger using Razor Pages, Bootstrap, and a little bit of JavaScript. This tutorial is part of the C# pathway that can be found in the csharpacademy.com. This is a tutorial for absolute beginners in Razor Pages, but you do need to have a little bit of experience with C#. This is a practical tutorial, so I'm not going to explain every little detail of what's going on behind the scenes. I'm going to post several links so you can dive deeper into anything you have questions about. Don't forget to take notes so you can retain knowledge more efficiently. Also, don't forget to hover over the code in case you don't know what something means. C# does a very good job at explaining the code. And if you get stuck, don't forget to use the debugger and to use Google to research your errors. And you can also find us in the C# Academy community on Discord. If we compare a classic MVC project with Razor Pages, in MVC you have what we call a front controller that centralizes the code behind for every view or for multiple views, while in Razor Pages you have a controller for each view. So it's still a form of MVC, but with decentralized controllers. So let's get started. I'm using Visual Studio 2022 for Mac, but of course you should be able to use Visual Studio for Windows or Visual Studio Code for Mac, or even in Linux. You shouldn't have any problems to follow this tutorial. The type of project we are choosing is web application, so be careful not to choose anything like Blazor or MVC, otherwise your initial project will look very different. We're going to target the latest version of .NET. We're not going to use authorization in this project. That's going to come in a later project, and you can choose to use HTTPS or not, but make sure you always use HTTPS if you want to publish your project, if you want to deploy it for other people to use. Then you're going to choose a name for your application. The solution name can be the same. Choose a folder and keep the option checked for put project file in a subfolder. I always like to keep projects in subfolders. For this project, that shouldn't be an absolute necessity since you have just one project, but think that a solution contains multiple projects. So when your application starts growing and you need multiple projects for a solution, it's good practice to keep them in subfolders, and that also helps a lot with source control, so your source control repositories are nice and tidy. I'm not choosing to work with Git in this project so that this video doesn't grow out of control, but it's up to you to use it or not. On the right side of this dialog, you can see the structure of the project you're about to create. We have the solution file, we have a subfolder, and inside that folder we have the csproj file, which relates to your project. And then let's hit create. If this is your first time creating a project with .NET, you are confused. I totally understand. I have been there. You can see a bunch of files and folders that you haven't seen before, and you have no idea why. My first piece of advice here is don't panic. All we have to do is study piece by piece, and eventually we will understand what everything does. Also, it's very important to understand that one project won't make you an expert in Razor Pages or anything for that matter. It will take some time, some experience, some pain. You will have to create a few different projects. You will get stuck. So if you get stuck, don't think that you're not made for this, or don't think that .NET's not for you. It's just natural. Everyone has been there. Every developer has experienced this before. The first folder you can see here is called Connected Services. We're not going to be using it in this project. It's used to help you connect with services in the cloud and other APIs. But as I said, we're not going to use it here. Then we have the Dependencies folder. That's where you visualize anything that your project needs to run. So right now we just have the frameworks that we're using to run this project. And later we're going to have information about any libraries that we use. Then we have the most important folder for this project, the Pages folder. We're going to spend most of our time working in this folder. Now, as you can see, there are many files here. Again, it can be confusing, but keep this in mind. The objective of these files is to generate HTML. At the end of the day, all these files are combined and generate HTML for your web page. That's it. So let's have a look at this basic structure. Here we have a shared folder. It's going to contain anything that can be used in multiple parts of your application. Example, the header, the menu, the footer, or anything else that you want to create that will be seen regardless of the sub-page that you're in. Now you can see here that this file follows the exact same structure of a normal HTML file. It has a head with all the information about the scripts that you're using and CSS. It also has a header, which in this application we're going to use for every page. And it looks very crowded and busy, mainly because of the CSS classes that are being used here. These classes are Bootstrap classes. If you don't have experience with Bootstrap, it might be a little bit overwhelming at first. And I do recommend that you watch a Bootstrap crash course. So .NET ships its applications straight out of the box with Bootstrap installed. So we are ready to style our application any way we want using this powerful library. That doesn't mean that you have to use Bootstrap. You can remove all the Bootstrap files and install different libraries that you want to use, but we won't touch on that right now. Our objective is to build a nice application, and for that we're going to use Bootstrap. Then we have our validation scripts file. So that's going to be a partial. Partials are files that we can include in any part of our application. So this partial will contain information about the scripts that we use for validation of our forms. Then we have our view imports file. That file is used to centralize everything that we are going to use repeatedly in our application. So let's say you have a data folder or a services folder that you're going to use in every single file of your application, in every single class. Instead of repeating that code, all you have to do is put it in the view imports and it will be available, which makes our code way cleaner. Then we have our view start file, which contains code that will run at the moment of the execution of each page, and it's going to affect any page that's within the same folder of the view start file. And the most common use for this file is to set the layout for each page. Then we finally have the pages that are actually going to be displayed. This basic application that .NET ships for the Razor Pages project has an error page and a privacy page. The one that really matters is the index, which is set as the default homepage for our app. We're going to see later how that's done. Then we have a properties folder with a launch settings file, which contains information about how our project will run. And then another very important folder, the www.root, which contains all of our static files. So it ships straight out of the box with a JavaScript file where you're going to write all of your scripts, a CSS file for the styling, and Bootstrap and jQuery, which is a very popular JavaScript library in which Bootstrap relies upon. Then we have app settings.json, which contains information about configuration of our app, such as connection strings. And lastly, we have our program.cs, which is the starting point of the app. Here we create an instance of the web host interface, which is a web application, and we call a bunch of methods that will support this app. So there are methods related to HTTPS, to using static files, use routing, use Razor Pages, and finally the method that will actually run the app. Later, when you learn how to modify this file, it's very important to keep in mind that these methods need to run in this exact order, otherwise you might run into errors. If you run the app, you can see the result, which is a full-blown web page. We have a navigation bar on top, a footer in the bottom, the index page with the welcome header, and if we click the links in the navigation bar, we are redirected to our pages. And you can see that this website is fully responsive. If we decrease the size of the screen, we can see that the menu becomes an icon that's clickable, and that's provided by Bootstrap. Everything that you've seen so far is the result of what we call scaffolding. That means that .NET has a basic template, a basic boilerplate for each type of project that we want to start. A Blazor application has a different one. A web API, even a console application with that single program.cs is arguably scaffolding, but that doesn't mean that you need to scaffold your initial application every time you're going to use it, every time you start a new project. With experience, you will be able to create projects from scratch. You might also start your projects cloning other projects and modifying as you need. So scaffolding is very useful when you're first learning how to code, and it's a very nice feature of .NET, but that doesn't mean that we are going to use it every single time. So now we are somewhat familiar with all the files. We have some cleaning up to do. First, let's go to the layout file and let's remove the navigation link that we don't need. We're not going to need a link for the privacy page. And I'm also changing the text of our navigation link from home to water drinking logger. Then let's delete the error.cs HTML and privacy pages, since we're not going to use them. Let's remove all of the content from the index page, and let's go to program.cs and remove the use authorization, since we're not going to use it. If we run the application again, we can see the modifications. So now we are finally able to start working. Let's start in our app settings.json. Here we're going to configure our connection string for our database, and we are going to create a database manually using DB Browser for SQLite. If you haven't used DB Browser before, have a look at the links below. There is a resource to learn the basics of DB Browser. The first step is to click on New Database. Make sure that the name of your database is the same name as in the connection string, and also make sure that you create your DB file in the same folder as your project. Not the root folder, but the subfolder where your CS project is. Then go to Execute SQL and run this script to create your table. You can find it in the README file of the GitHub repository for this project, which is in the links below. You don't need to know a lot of SQL to follow this tutorial. We are only going to create very simple queries so that you are able to execute CRUD operations against the database, plus this initial create table query. If this is your first time using SQLite, bear in mind that it only supports 5 types. That's why we're storing the date as a text, since SQLite doesn't have a date type. Also, notice that the quantity property is an integer. That means that we won't be able to use split quantities. For the sake of simplicity, we are only going to use full numbers. If you did everything correctly, you should see your database file in your project folder. So now we can start writing some code. So let's go to our index page and create a button that will link to the page where we can add a new record. So now that button was created. Now, before moving on, let's take a closer look at the code generated in this index page. In any front-end solutions that are part of the .NET framework, you will connect C# with HTML using Razor syntax. This is a very clever solution so that we can use server-side code to generate HTML. It's very powerful, and I would say almost magical. There is a lot that you can do with Razor syntax. And the good thing is that once you learn it, you can use in MVC projects, Blazor projects, or anytime you want to generate views using the .NET ecosystem. In Razor syntax, we use the @ to plug C# code into HTML. Here we can see a few examples of that. We have the @page on top, which means that this is a Razor page, and it's one of the main differences between a Razor view and an MVC view. Then we have the @model, which in this case is the index model. In Razor pages, by default, the name of the model will be the same name of the page. So when we create a delete page, we're going to have the delete model. And that model, that class, will be declared in a different file, which provides a very neat separation of concerns. We're going to have a file for the view and a file for the model, which is the so-called code behind. Now, whenever we have multi-line C# code in a view, we need the @ plus curly brackets. And this is what's happening here with this ViewData. The ViewData to pass data from server side, from your index model or from your page model to the view. You're going to declare that ViewData in your model class, and then you can use it as you wish. Now let's have a look at the button. It's just a normal A tag of the button type. Then it has a couple of bootstrap classes so that we style it nicely. And then we have another very important feature of ASP.NET, which is the tag helpers. Here you can see 2 tag helpers, ASP area and ASP page. The ASP area is not going to be used in this project, but it's very important when we create bigger projects with multiple areas. It's going to assist us with routing. So let's say you have a large application with an administration area and a public-facing area. You would declare that with the use of ASP area so that you could be redirected to the correct pages in the correct areas. But we are going to use the ASP page, which will redirect us to the pages that we want. In this case, we created an add record button that is going to direct us to the create page. Ultimately, HTML code will be generated, and in this case, it's going to be an href, which will link to the create page. So now let's create the create page where we're going to add records to the database. So I'm right-clicking the pages folder, choosing new file, and in ASP.NET Core, I'm choosing Razor page with page model. The name of the page is going to be create. So here we have the create view with the create model. Let's start with simply creating a header, add new record in between H2 tags. If we run the application and click the add record button, we're going to be directed to the create page. If you look at the generated HTML, you can see that we have just a normal HTML file that was rendered with the help of Razor syntax. And everything works fine. So now we need to create the form so that the users can insert data. So here I'm pasting some code that will create a form for us, and most of it is just HTML with a bunch of bootstrap classes. So I'm not going to dive into that. What's important for us here, C# learners, are the tag helpers. Here we have a few tag helpers with the word for, and that means that they are helpers for properties of our model, of a type that we want to work with. We're going to create a drinking water class that will represent our table. We're going to see how we're going to bind this model to the view soon. But here we are creating two inputs and a button. For each input, we're going to have a label and the input itself. And we're declaring with the tag helpers which properties of our model the label and the input are for. So the first one is the label for the date property and the input for the date property. That means that the generated HTML is going to be of the type date. For the quantity input, the generated HTML will be of the type number, since our quantity will be an integer. Then we have a button that will submit this form, and it knows where it's going. It knows where it's sending the data to because it's in a form within a Razor page, and behind the scenes we're telling that button that we want to reach the controller in the create model file, which we will examine soon. To finalize this view, we need to insert the validation scripts partial correctly. Now, before working with the page model for the create page, let's create the model for our drinking water table. So for that, we're going to create a new folder called models, and let's create a new class where we're going to declare the properties of the drinking water model. This model will have the same properties that our table has, with the difference that date won't be a string, it will be of the type datetime. Now let's finally look at the code behind for the create model page. In the code behind files in Razor pages, we're going to see methods that represent HTTP requests. So here we can already see the onGet method. In Razor pages, the name of the methods have the on plus the HTTP verb that it relates to. If you haven't seen this action result type before, it's heavily used in controllers in the .NET framework, be it for Razor Pages controllers or API controllers or MVC controllers. And that provides us with a set of standardized responses that are very commonly used in these types of classes. Action result supports many types of responses, including content responses, redirect responses, and status responses, which are very commonly used in HTTP requests. Don't worry too much about that right now. We're going to be using various types of responses for the action result methods, so we will learn them as we use them. The onGet method is used to initialize any state needed by the page, but since we don't have any state needed for the create page, we are just going to return the page. But now the next step is to bind our water drinking model with our form. So let's declare the water drinking property in our create model. So the drinking water property will be of the drinking water model type, and we need the bind property tag so we can connect it to our form. And that's one of my favorite things about a strongly typed language such as C#. We always need to declare the types so that when we're passing data around, we know exactly what type of data we're talking about, making the lives of the developers way easier. Now, the next step is to create the code that will handle the submission of the form. So for that, we need to inject our connection string into the create model. And we're doing that by using the iConfiguration class and dependency injection. So we are inserting the configuration class into the constructor of the create model class. Then we are creating an onPost method, which will be triggered when we submit the form. This method will have a return type of action result. And then we can see for the first time a very important feature of Razor controllers, and that is the model state. The model state is a big object passed from the form every time we submit a post request, and it's used to validate the form. It informs us if the form has any errors, so it's heavily used in validation. We're going to see an example of validation in the end of this tutorial, so let's just leave it here in the beginning of this method for now. Then we need to create the code that will actually create the data in the database. We are declaring a SQL connection, opening the connection, creating a command, declaring what that command is, and that's an SQL command. We are executing this command, and we're using the execute non-query because we are not querying the database, we're not asking questions from the database. And then we are closing this connection, which is a very important thing to do since connections are unmanaged resources. If you don't close them, they're going to occupy memory, and in big applications, this can be a huge problem. For interaction with the database in this project, we are using ADO.NET, which is a data access solution provided by .NET Framework. And I highly recommend everyone starts with ADO.NET since you are forced to learn SQL syntax properly. So make sure you're learning that before learning mapping libraries such as Entity Framework or Dapper. And here we're going to use one of the return types provided by the action result type, and that's going to be redirect to page. So after the record is inserted, we're going to redirect the user to the index page. However, you can see that the compiler is complaining about something. It has a squiggly line under the SQLite connection declaration, and that's because we need to import a package, a NuGet package for this dependency. So we need to import the Microsoft.data.SQLite. And once that's done, we can add an using statement for the SQLite connection, and then the compiler is happy. So let's run the app and see if it works. If we go to the create page, we can see a decently looking form with a date picker as a date input and a number input for the quantity. Let's try to create a record, and we get an error. That error happened because I didn't actually create my table in DB browser. When you're using DB browser, after executing your SQL query, you also need to click on write changes, otherwise it doesn't confirm your changes even after you have executed the query. Once that is done, you can run the app again, try to insert the data, and it will be persisted. To visualize that, go to the table in DB browser and click on the tab Browse Data. Now it's time to work on the index file where our list of records will live. .NET ships the index page as the main page of our application, and initially it has a logger injected into the controller, but we're not going to use this logger in this application. Instead, since we want to load all the records every time we load the page, we're going to call the getAllRecords method from the onGet method. As we said before, the onGet method is used to set any state needed by the page. We're also declaring a list of records as a property of the index model. Then we are injecting the configuration into the index model constructor. That's where we're going to get the connection string from. Then in the getAllRecords method, we're going to call the database to fetch the list of records. As we did in the create page, we are creating an SQLite connection, passing the connection string as a parameter. We open the connection, create the command, and in this situation, we create a reader. The reader will work inside a loop, and as the reader reads the data, we are adding records into a list that was declared inside the getAllRecords method. If we examine the loop, we have a tabledata.add. We are adding a new drinking water model, and for each property, we are collecting the data from one column. The number of the column is declared explicitly. For example, the ID is calling a method from the reader that gets specifically integers, and as a parameter, we have the number 0 inside the braces, and that's the number of the column. Since the return type of this method is a list of drinking water model, we can't forget to return a list in the end of the method. Now let's see how we're going to show this list. We're going to use an HTML table with the ID of records. This table is going to have a thead tag, which means that we are working in the head of the table. Then we have a tr, and a couple of th tags, which means table header cell. And here we are using a different way to mix C# with HTML, and these are the HTML helpers. These are methods that have as arguments C# code, and I'm mixing these two ways to handle HTML with C# because you will come across both in your C# journey. HTML helpers are the legacy solution, so even though Microsoft isn't encouraging you to use them anymore, you will still find them all the time when you get a job or in other tutorials. Then, in the body of the table, we're going to loop through the records to generate the table data cells, also inside of table rows. So for each record in the model.records, which was declared in our code behind, we are generating a row with a couple of cells, one for the date and one for the quantity. And we will have another cell with a couple of buttons, one for the delete function and one for the edit function. These buttons will redirect the user with the help of ASP4 tag helper, and will also pass the ID of the record using the ASP route ID tag helper. If we run the application, it should work fine, but instead I get an error. Let's see what's going on. In the onGet method, I forgot to assign the list of records as a call to the getAllRecords method. So there was no connection between my records property, and the database. With that fixed, it should be working now. When we load the first page, the record is already there, and you have a nice list with the buttons. The next step will be the creation of the delete page. So we're creating a new file that's going to be a razor page with a model. Its name is going to be delete. And since the structure of the code behind is the same, I'm going to open the index method in a separate window inside Visual Studio so I can copy and paste some code. So I'm going to use the same technique to inject the configuration into the constructor. Then I'll bind the drinking water model to the page, and in the onGet method, I'm going to call a getById where I'll fetch information about one record, and I'm assigning the drinking water property to that method, passing the ID of the record. Inside the method, I'm declaring a new drinking water model object and fetching a row of the table with information about one record, passing the ID, similar to the way that we got all the records, except that we are getting just one record. Don't forget to return your drinking water record. And in the delete page, we will also have an onPost method. And you might be asking yourself, why are we using an onPost to delete? And the reason is razor pages are made to be used with views. And since in views we use forms, and forms don't delete or update, it makes sense to call the methods that are associated with these actions only post or get. So when we update or delete, we're going to post a form to execute these actions. And here we create a SQLite connection again and pass a very simple command to delete a record. Once that's done, we redirect the user to the index page. In the view, we are asking for a confirmation from the user. We ask if they are sure they want to delete that record, and then we show information about that record. For that, we are using displayNameFor method for the labels and the displayFor method for the data. Then we have a delete button and a link in case the user wants to go back to the list. Notice that this button is inside a form so that it triggers the submit method or the post method, and it has an hidden ID input. With that, let's run the app and see if it works. Let's just add a new record first so that we don't end up with an empty table. And once we press delete, we are redirected to the delete page with the information about the record. And once we delete, it doesn't work. Let's see what happened this time. If we take a close look at the onPost method, we will notice that I forgot to execute the command. So let's add the execute non-query method call, and with that it should work now. If we run it again and try to delete, this time the list will have only one record. Now let's create the page to update a record. We're creating a new razor page with a model which is called update. And similarly to what we've done before, we need to inject the connection, the configuration into the constructor to get the connection string, And very similar to the delete page, we are also calling the getById method so we can show data from the record that we want to update. That method is an exact copy of the one we have in the delete code behind, but the onPost method will be slightly different. It will be more similar to the onPost method contained in the create page. And that's because we need to validate the form, and for that we are using the model state object. Once the form is validated, we are sending an update command to the database, and this time let's not forget to execute the query. Once that's done, we are redirecting the user to the index page. In the view, we're going to have a form very similar to the one we have in the create page. With the validation script in the end, we're also changing the header. And since we are binding the form with the drinking water property, and this drinking water property is being assigned to the getById method in the backend, once we load this page, the form will be populated with data from that record. So let's see what happens when we run the page. We're clicking on edit, and as you can see, the form has data as we wanted. Let's update, and this time it works. Let's try again just to make sure it wasn't luck, and it works again. We finished the functionality for the app. Now let's work with the styling of the application. The first thing I want to do is to change the logo. For that, we're going to create a new folder inside the root folder that's used for the static files, and that folder is going to be called img. It will contain our images. I downloaded this picture from the internet, and it's going to be available in my GitHub repository for this project. I'm also modifying the nav header, removing 2 bootstrap classes because I want it to be transparent. So these are navbar light and bg white. And I'm also removing the a tag for the water drinking logger, since my logo will already contain a link to the main page. For the logo, I'm adding an image inside the a tag, and I have to be careful to pass the correct path for the image. And when I run the app, the logo is there, but it's quite big. Let's see how we fix that. In the site.css file, where all of our styling is centralized, we are adding a reference to the logo class and assigning 80 pixels to the width of the image. So when we run the app again, the logo has a decent size. Now the next step is in the layout file. First, we have to wrap all the content of the body into a div with background as a class. And since I wanted to change the opacity of this background, I had to bring in some code that is quite complex CSS in my opinion. And I don't really know what's going on with this code, but I'm not a front-end developer, so to be honest, I don't really care. As long as it works, this code obviously will be available in my GitHub repository. So if we run the app again, it looks way nicer. The next step is to change the buttons. And for that, I'm going to use a color palette. I highly recommend you always work with palettes. That's the best way to have a website with colors that work well with each other. And my palette is based on the background image. So I'm using this website, very nice website called Coolors, where I can choose different palettes based on colors of my image. If you choose a different image, make sure you jump into this address and play with the colors so you can make your website look nice. Once you're happy with the colors, you can choose go to generator, and you'll be able to see all of the hex codes for the colors that you picked. Back to the CSS file, I'm overriding the colors of the bootstrap buttons by declaring a new color inside the existing classes already provided by Bootstrap. Back to the index page, I'm adding icons to the buttons. So I'm using SVG that can be found in the Bootstrap documentation. So I'm pasting the code from the documentation into the A tags, and that's code for the icons. And needless to say, it's going to be available in my repository. If I run the app again, we can see that we have a more coherent set of colors for the buttons. But I didn't go as far as changing the hover colors for the buttons. Feel free to add that to your project if you want. And to tidy up the form a little bit and separate the fields, we're adding a margin, a bottom margin to the form group class. If we run the app again, the form looks a little bit better. Now, as a bonus, I'm doing a little demonstration of how we could use JavaScript with Razor pages. On the index page, let's create a different button with the onClick event handler triggering the calculate method. Then let's go to the site.js file and create a function called calculate. In this function, we are declaring a variable called table and storing the table, getting it by ID, which is records, and we're also declaring a variable called result. Ultimately, we will show the result of our calculation. And what I want to calculate is the sum of the drinking water quantities from each row. For that, I'm using a loop and I'm adding the value of each cell that contains quantity to the previous result. Once the calculation is done, I'm appending the result to the result area div created in the view. Let's just add some text to the button, otherwise it will be a very strange looking button. And let's run the app again. So let's add a new record. Now we have 2 rows, and once we calculate the total, the result is appended to the div. If we examine the generated HTML, we have the result text inside the div. We're getting closer to the end, but first we need to have a look at a very interesting concept in .NET, which is the data annotations. These are tags that we can attach to properties in our model, and they are mostly used for formatting of your properties and validation. In our model, I added a display format annotation for the date time so that the date is always displayed without the time, and for the quantity, just to demonstrate validation in Razor pages, I included a range. And basically this range will prevent that the user inputs a negative quantity. It also provides a message that will be displayed in case the user inputs the wrong input, and that message will be displayed with the help of the ASP validation for tag. In our form, the validation is just under the input in a span tag. So let's see the result. The date now is being displayed with the format that we specified. And let's try to add the wrong input. So if I input a negative date, now I get an error message. Before we finish, let's see how we can use the ViewData property to show the total quantity of water drank. I'm declaring it in the onGet method and using a C# equation with the help of a link query to get the total sum. Then, using the @ sign, I'm adding it to the view, and as soon as I load the page, the sum is already there. If I add another record, the page loads again, and the new sum is already there. So we have 2 ways to calculate the total, and that's it, we're finished. This tutorial is part of the C# pathway that can be found in the csharpacademy.com. Please subscribe if you enjoyed this tutorial. There are many more nice projects to come, and find us in our community on Discord. See you next time.